friends, welcome to VTeach. Today I want to deal Advanced Encryption Standard AES. In previous class I have explained DES, Data Encryption Standard. In that class how the permutation will be implemented, how many rounds are generated for generating cipher text. In this AES, mainly the major advantage is the plain text size is we can improve more. In DES actually maximum size is 64. In this AES we can increase 64 to 128, as well as the key size will be more. How we are taking the plain text, and by using this 128 bit key we are generating a cipher text. Coming to the AES is a block cipher technique, as well as DES also it comes under block cipher, and this AES also comes under block cipher. It is using mainly two types, substitution and permutation. What do you mean by permutation? Permutation is nothing but rearranging the elements, and substitution means we are substituting the value with another value. When you are implementing this permutation and substitution, our plain data, that is original text, will be more secure. And the another thing is here the number of rounds depends on the key size. So how many rounds? In DES maximum you can implement 16 rounds. For example, here when you are taking 128 bit key size, it dictates 10 rounds. If my plain text size is 192, then I will implement 12 rounds. If it is 258, then it has 14 rounds. So the key size will be depend on the size. Now this is the normal procedure how to apply this AES. So I am taking a secret key and I am taking a plain text. If it is a 128 bit plain text, and I will get 128 cipher text. 192 to I am taking plain text, I will get 192 cipher text. And the round also, if it is a 128, it is a, already I explained here, 10 rounds. So it is a 10. If my plain text is using 192 bit, it is 12. It is a 256, it will generate 14. So here I am taking the secret key and I am taking plain text. So here I am implementing my different rounds. Finally I will get the cipher text. Now we will go in depth. What is the encryption and decryption process of this AES? This is a structure of the AES, Advanced Encryption Standard. Like in AES also, the plain text you are taking, that is 16 bytes. First you are adding a round key. So in the next slide I will explain how to take the round key, and we are applying substitution bytes. That means you are implementing S box. After that, shift rows. So you are performing left shift or right shift. You can perform any operation. After that you are performing mixed columns. Here mixed columns nothing but you are taking a predefined matrix and you are multiplying with the predefined matrix. Finally you will get one output. Finally you are adding again key to that matrix multiplication table. So in this way you are repeating the same process for all the rounds. So if my input bit is 128, I will get 10 rounds. And another thing is, in round 1, round 2, I am taking add round key. So after round 3, 4, 5, 6, 8, 9, there is no need of add round key. In round 1 and round 2 only you are taking the key. The rest of all the rounds, no need of using this key. So finally you will get the encrypted text, that is cipher text. After applying decryption, you will get the plain text. So this is the decryption process. So what is the decryption process here? So exactly opposite to the encryption process. So again you are taking add round key, inverse shift rows, inverse sub bytes, and again you are adding add rows, and again you are doing inverse mix columns. So round 1 to round 10. If my input is 128 bit, then I will use 10 rounds. If it is increases, then automatically the key size or the rounds will be incremented. Now, in Advanced Encryption Standard, mainly you have 4 steps. By using these 4 steps, you are converting your plain text into ciphertext. The first one is substitution of the bytes. Second one, shifting the rows. Third one, mixing the columns. And finally, add a round key. Now coming to the substitution of the bytes, in the first step, the bytes of blocks text are substitution. Substituted means you are replacing with another value. So now we'll see one by one how the bits will be substituted, how we are shifting the rows, and how the multiplication will be done. Step by step we will discuss. Coming to the first one, substitution of the bytes. In this substitution, we are taking 16 cross 16 matrix, because in this substitution, let us see this diagram. In AES S box, it is generating X and Y. So the matrix size is 16 by 16. 16 rows and 16 columns. So how you are taking this value? So initially I am taking 0, 1, 2, 3, those values. Now convert these values into hexadecimal. Hexadecimal. First you are taking plain text. So first I am taking the plain text. After taking the plain text, you are converting into ABCD alphabets. Again, after that, convert all the characters into hexadecimals. So prepare a hexadecimal values. For example, A, maybe I will get 0, 0. So maybe S, so maybe 1, 1. Like that, you can generate hexadecimal values for all these characters. Now, I have generated here 16 cross 16. That means total 256 elements. This is the 8-bit output value. Next, after preparation of this S box, let us consider I have taken one input. So this is the hexadecimal values EA G4 16. So let us consider, for example, my plain text is welcome to VTeach. So first of all, I want to convert this plain text into 4 cross 4. 4 cross 4. 1, 2, 3, 4. 1, 2, 3, 4. So I am substituting W, L, C, H. So here, this is welcome to VTeach. This is my plain text. Now I am converting this plain text into a 4 by 4 matrix. So this is a 4 by 4 matrix. Now I am converting this table into hexadecimal values. Hexadecimal values. So finally I will get these values. Now here I am applying subbytes of transformation. So I want to get substitution EA. So what is the value of EA? So E means this one. So E, and what is the column wise? A. So here I am taking the intersection point of the value. So what is the intersection of E and A? The value is 87. So here I got 87. Now similarly I want to find out 6, 5. So 6 represents row and 5 represents column. Now I want to find out the intersection point. So 6. This is the sixth one. So column wise 5. So what is the intersection of this 6, 5? 4D. This is the 4D. In this way, I will get 4 by 4 matrix of the transformation. Initially I am taking plain text and I am converting into hexadecimal. After conversion of hexadecimal, again I am arranging it into a 4 by 4 matrix. After that I am performing transformation. So the first step is completed. Next, second step, shifting the rows. When you are performing this shifting the rows, so you should remember these 4 rules. What are the 4 rules? When you are taking the first row, there is no need of performing shifting operation. When you are taking second row, you should use first left. I mean 1 byte left shift. If it is a row 3, 2 shifts, and it is a row 4, 3 bytes left shift. Suppose S00, 01, 02, 03. So row 1, there is no shifting. So no need of doing left shift. Now coming to, so this is row 1, this is row 2, this is row 3, and this is row 4. In this row 2, I need to do 1 left shift. So that means shifting nothing but here shifting. So observe this output here. S10 comes here. This is 1 left shift. So remaining are in this way. Sir, and next third row 2 bytes. So 2 bytes means these 2. So these 2 comes in this place. So S20, S21. So remaining are this way. For row 4, 3 bytes. So next time these 3 this place. So S30, 30, 31, 32. In this way I am performing shift to row transformation. The second process is also completed. Next one, mix the columns. In this mixing the columns, here this is a predefined matrix. Already have generated mixed columns. So in mixed columns, I am taking this is predefined matrix. Now you are multiplying with our transformation matrix into predefined matrix. Already we have, this is the matrix values. Okay, this is row shift matrix. So this is the output. So when you are multiplying these two, I will get this output. Example 8742. This will be converted into, this is the output. How you are performing multiplication? So this is 4 cross 4. So I am taking 2 0 1 1 0 1 0 1. So how to perform matrix multiplication? If the matrix size is 4 cross 4, here also 4 cross 4. So this 02 into 87. This is the first one. Next 3 into 6e. 3 into 6e. So like that you are calculating the matrix multiplication. Finally adding a round key. So repeat the same process for all the 10 rounds. So this is the adding round key. So here you are performing XOR operation for the generated matrix multiplication. That means mixing the columns. So you are taking input and this is matrix multiplication. So you are applying XOR operation. So this is the final ciphertext. So in this way you are repeating the same process for round 2, round 3, 4, 5, 6, 7, 8, 9, 10. My input size is 128. So I can perform 10 rounds. If my input size is increases, if it is a 192, I can use 12 rounds. So repeat the same process for up to the last round. Finally you will get the ciphertext. Okay. So this is the procedure of AES, Advanced Encryption Standards. Thank you for watching.